Okay, today we're going to be looking at the curvature over Lake Pontchartrain, the apparent curvature of Earth. Over this distance, if you count the pylons, and there isn't really information out there about how far apart they are, but according to the standard, which is weird, right? I mean, you can't find that simple information anywhere on the internet. But according to the standard separation of these things, it's about 300 to 400 meters, so 980 to 1,300 feet. So what we're looking at is we're looking across Lake Pontchartrain to the tower on the other side of these transmission lines that is about 15 miles away. So the tower that we're looking at on the other end is about 15 miles. And I could be wrong about that too, because I don't know. I've been to Lake Pontchartrain once in my entire life. And when I went there, I wasn't looking for curvature of the Earth. I knew the Earth was a globe back then. So I couldn't tell you for 100% fact because, like I said, publicly available information about this is not that great. But I'm estimating by counting the pylons that the curvature effect, where we see it start to take place, is about 8 miles. And depending on how high he is above the surface, you really shouldn't see curvature like that over 8 miles. And that's obvious. And you can see what's happening. I mean, if you look at the picture, you can see there's definitely an inversion. And we see this a lot over Lake Pontchartrain, where you get the inverted effect. And we're going to look at another picture where we don't see it. But when that happens, you get this twisting. And we saw that if you've been watching my videos, we did a video where we were watching a boat sail away and appear again to go behind the curvature of the Earth. But we watched the entire boat keep its angular size above the horizon that it should be on a flat Earth. And because the light is hitting the ground over distance, the bottom of the boat disappears. Because if the light from the bottom of the boat coming parallel or at an angle to my eye is refracting down, like atmospheric refraction says on a flat Earth, it's going to hit the surface. Okay, so if the light is hitting the surface over distance, it's not going to hit my eye. And because that light is still coming down to hit my eye, it is increasing the angular size of that object on the horizon, but it's keeping the angular size based on what it should be above the horizon. If you look at the top of the object and the light, because the light is hitting the ground, the bottom part is stretched out. And you'll see it continue to stretch. We're going to look at examples of this. There are any example of Earth curvature that you could look at, you can see that. But we're not paying attention to the inversion and what's going on in the foreground. Anyone who is really serious about this subject on either side is not going to look at the inversion and say, oh, this is curvature. You see a lot of people making videos that this proves the curvature of Earth based on what you can see here with the pylons bending back towards the observer, never really looking and examining these images, zooming in, looking at what you're looking at. It's just, you see the curved power lines because of this perspective shot, for one. And you get that inversion effect over the water at about 8 miles, it looks like, which we should not see the last pylon in the water at 8 miles with Earth curvature anyway. Regardless, even if he's 6 feet above the surface, you wouldn't see that. So he's clearly higher than that. We're looking, though, at the tower at the other end. And if you look at this tower, okay, so what I want you to notice is there are three things at the top of the tower, and then the tower widens out. But this does not match the shape of the tower after the light has traveled through the atmosphere. There is definitely distortion taking place here. But you can vaguely, if you look really closely, you can see the X's, and we can count 1, 2, 3, and then the bottom one hits the surface of the water. So I would make the argument that refraction is causing the bottom portion of the pylons, and I'll show you down here, the very bottom portion of that object to be hidden by apparent curvature. Now, the problem with that is depending on how high he was above the surface, if I'm 20 feet above the surface of the water or 15 feet above the surface of the water, I'm going to see 70 feet of that tower should be hidden by earth curvature. And the angular size of that tower should not be sticking where it should above all of the other towers in the foreground. Look at how high that is. And think about the angular size when we're looking at the mountain. You can calculate these things, but you really have to know the size of the object you're looking at. And for whatever reason, that information is not publicly available. But if you look at the top of that tower, where that tower is, we can see the 3 transmission portals. And then you go down and you see the first X, the second X, the third X, and then you see that bottom. You can barely see the bottom X. But you can see the entire outline or where it should be, right? And then you see the surface of the water. So we're not necessarily seeing the pylons, but the majority of that is not being hidden by earth curvature, just the very, very bottom of it. And again, it is apparent earth curvature. It is an effect that is happening because look at this picture. Look at what's happening here. They're fading into the distance. They're fading into the horizon because that lower level right above Lake Pontchartrain on a humid day is going to be thick. And so it's like you're looking through the mist. And that is going to be variable every day. That's not going to be the same every day. Your conditions over the water are going to change. Sometimes you're going to get that inversion where it bends the towers back towards you. I mean, honestly, if you think that is curvature, you have major cognitive dissonance going on. And if you can't see that the atmosphere is bending light and that the top of the tower is where it should be, I mean, it's magnified. The angular size is a little larger because, again, the light over distance is traveling down to my line of sight. And because it's at an angle through that gradient, it's bending down. And if we're looking at the bottom of the tower, so we'll say we're 30 feet above the surface. If I'm looking at the bottom of the tower, the angle 15 miles away to the bottom is 0.021 degrees. So the angle coming up to my eye and either refracting down or refracting up, I argue it refracts up. But if you say it refracts down, it's speeding up and then slowing down, there's some magical mechanism, then the 0.021 degrees is going to hit the water over that distance. And everything above that, so anything below my side above that is going to be at a shallower angle than that angle. And on a globe, that's what they're arguing. I mean, if you're seeing the bottom of the object or the lower portion of the object that's behind the curvature lifted up above the horizon, the light is bending down over the curvature from the bottom of that object and lifting the entire object above the horizon. But clearly, I mean, if you're going to argue this is Earth curvature, you can't argue the reason we see the entire tower at the other end is because of a refraction. You can't have it both ways, right? You can if you describe it the right way, because there are clearly 2 effects that are happening here. You have the inversion, which is causing this right above the water, right near the observer. And then over a greater distance, you have refraction, the light hitting the ground over the distance. The top of the tower is completely visible. The middle of the tower is completely visible. The bottom of the tower is completely visible. The only part of it, based on the shape, based on what we're looking at, is the pylons maybe are below the apparent horizon. But it's apparent and you can see it here. If you're imagining, like I said, the tower at the other end going behind curvature, the top of that tower is going to sink. It's not going to stay where it should be and stretch down. That is not curvature. The top of that object should be lower, right? If all of these towers are bending over the curvature, which they're not, the top of the tower at the other end should be lower than it should be. Not where it should be, where if something's disappearing, it's disappearing down here, but the top stays where it should be and everything is just stretched down to the surface, which is exactly what we see. I challenge anybody, show me any picture of Earth curvature and I will show you this stretching effect because the light is hitting the ground over distance. That is my argument, and I believe it's the right argument. And as we go through this, hopefully you'll at least question these things.